Yes, welcome back, dear students. So yesterday, in the previous video, I have skipped with the topic of introduction of gradient of a scalar field. So here is the definition. So if phi of x comma y comma z is a continuously differentiable scalar function, then gradient of phi is defined to be grade phi or del phi. So grade phi is equals to del phi is equals to dou by dou xi plus dou by dou yj plus dou by dou zk times of phi. So that is equals to, if you multiply phi for each and every derivative, you will get dou phi by dou xi plus dou phi by dou yj plus dou phi by dou zk. And also we have left with a few examples solving part. Yes, so here is example 2. If phi is equals to 4x z cube minus 3x square y square z, find del phi. Particularly they have given the point at 1 comma 1 comma 1. So here given phi is equals to 4x z cube minus 3x square y square z. This is the given problem. So we know that del phi is equals to dou by dou xi plus dou by dou yj plus dou by dou zk times of this function 4x z cube minus 3x square y square z. So here what we are doing is we are differentiating this function phi partially with respect to x and will multiply I. Will differentiate the same function partially with respect to y, will differentiate the same function partially with respect to z. So partial derivative, so dou by dou xi into 4x z cube minus 3x square y square z. If you differentiate this function partially with respect to x, we will get 4z cube minus 6xy square z. Since differentiation of 4x z cube is 4z cube, here 3x square y square z will become 6xy square z I plus, so derivative of this 4x z cube partially with respect to y is 0 minus derivative of minus 3x square y square z. So 3 2s are 6, x square as it is, z as it is, derivative of y square is 2y, so 3 into 2 will be 6. So minus 6x square yz j is the derivative of 4x z cube minus 3x square y square z partially with respect to y and multiplied with j plus derivative of 4x z cube minus 3x square y square z. The partial derivative with respect to z is 4 3s are 12, 12x z square x as it is minus 3x square y square, derivative of z is 1 into k. So now if you simplify with respect to the points 1 comma 1 comma 1, del phi at 1 comma 1 comma 1 is equals to substituting the value of x y and z as 1 1 1 respectively, you will get 4 minus 6i minus 6j 12 minus 3k. So finally the answer is minus 2i minus 6j plus 9k. Yes. Here is the third example. If phi is equals to x square yz plus 4xz square, find del phi at 1 minus 1 and 1. So again we know that del phi is equals to dou by dou xi plus dou by dou yj plus dou by dou zk. So the function is x square yz plus 4xz square. So del phi is equals to substituting the values for each and every derivative and differentiating. You will get 2xyz plus 4z square I. So this is the partial derivative of this function partially with respect to x. So next, x square z. So derivative of this same function x square yz plus 4xz square partially with respect to y and multiplication of j with that. Next, x square yz plus 4xz square, if we differentiate partially with respect to z and if we multiply k, we'll get x square y plus 8xz k. So we need del phi at the points 1 comma minus 1 comma 1. So here substituting the value 2 into 1 into minus 1 into 1 will get minus 2. So 4 into z square is 1 square, so 4 into 1 square is 1 I plus here x is 1, z is 1, so 1 into 1, 1 square into 1 is 1, so j. Here x square is 1, y square is minus 1, so 1 into minus 1 is minus 1, 8 into 1 into 1 is 8 k cap. So minus 2 plus 4 is plus 2 I j minus 1 plus 8 is 7k. So this is the answer for gradient. So that is del phi at the point 1 comma minus 1 comma 1.